Okay, here we have our subsystem demo for our power circuit subsystem. So basically what we're going to start off doing right here is we're starting off with the potentiometer completely open at 4.2 ohms, and we're going to be incrementing in terms of 500 ohms up until its full capacity, which is 5 kilo ohms. And so as you can see, you saw right there, it was 4.2 ohms, and now we disconnected it. So now we're verifying the transformer turns ratio. So our primary coming into our transformer is 121.6 volts AC, and then our secondary, as you can see, according to this voltmeter on the secondary transformer, is 26.30. So it's approximately a 5-to-1 turns ratio, which is what we expect. And as you can see by this multimeter up here, across the capacitor C5, which would be in parallel with our load, is 1.24 volts. Okay, now we're doing the test with the potentiometer incremented to 500 ohms. So as you can see right here by this ohm meter, it's close enough, approximately. Wait for it to come up here. 514.6 ohms. So now now reconnect it back into the circuit. I'm going to turn the power on. And as you can see up here, we have our voltage across the capacitor. So with an increased resistance added to the potentiometer, the voltage, it created more of a resistance path for the current to fall, not going into the resistance load. So more current's going to travel across the load now. So the voltage went up to 3.657 volts as expected.
Cool.
Okay, as you can see right here now, we incremented up the potentiometer to approximately 1 kilo ohm, and so now we got to connect the potentiometer back into the circuit. Now turn the power on. At 1,000 kilo ohms, it's supposed to be approximately 5.8 volts according to simulation. We're reading 5.97 volts. Okay, now we adjusted the potentiometer to approximately 1.5 kilo ohms, as seen by the ohm meter here, and I'll plug it back into the circuit and turn the power on. So according to the voltage across the capacitor, which would be the same voltage across the load, it's 8.342 volts approximately DC, and according to our expected results from all these, it was 8.07. Okay, now we adjusted the across the potentiometer to the resistance of 2 kilo ohms here, and so now we connect it back into the circuit. Turn the power on. Measuring the voltage across the capacitor, which would be the same across the load. As you can see right here, it's about 10.741 volts DC, and our expected value was 10.3. Okay, we adjusted the potentiometer now to be about half of what its full capacity is, to 2.5 kilo ohms. So now when we connect this back into the circuit, turn the power on. Okay, it's reading about 13.105 volts DC, and the expected value was approximately 12.6 volts. Okay, now we have our potentiometer set over halfway. It's at approximately 3 kilo ohms. So now we connect it back into the circuit and turn the power on. We're reading the voltage across the capacitor here, and it's reading approximately 15.45 volts. And according to simulation, at 3,000 ohms, it was supposed to be about 14.9. We adjusted the potentiometer further up 500 more ohms. It's approximately about 3.5 kilo ohms. So now we're connecting this back into the circuit. We're reading the voltage across the capacitor, and it's reading about 17.84 volts DC. And at this current multisim, it should have been about 17.2. Okay, and now we have our potentiometer to about almost fully closed at about 80%. It's reading about 4 kilo ohms here. It's now connecting this back into the circuit and turning the power on. Voltage across the load capacitor is 20.2 approximately. And according to the simulation, it was going to be about 19.4. Okay, now we're with our potentiometer at about 90% closed here. It's reading approximately 4.5 kilo ohms, with a little bit extra. And now reconnecting the potentiometer back into the circuit, reading the voltage across the load capacitor. It's about 22.62 volts DC, and according to our simulated model, it's supposed to be about 21.7. Okay, now we're at our final end of our first trial here. This is the potentiometer fully closed. It's approximately 4,638 ohms with it fully closed. And so now we're going to reconnect this back in the circuit and see the voltage across the capacitor that they could maximum output. And according to this, it'd be about 23.21 volts, and our simulated model had predicted about 24.